Hello students, welcome again to my channel. My name is Mr. Meshak Ngigi and welcome to eMath with Mr. Meshak Ngigi. So today we're going to be checking complex analysis, and in this particular lesson we're going to be checking something called the bilinear transformation. Alright? Yeah, so remember we checked in the previous videos, we have checked in inversion. So here we're going to be checking now something called bilinear transformation. Alright? So if you're not subscribed, can you subscribe, share and also comment and let me know how I can help out. So thank you, and now let's jump right into the lesson. So you have the question: find the image of the circle z equals to 3 under the transformation w equals to z minus 3j, then z plus 2j. So solution. Now, so the first thing that you do in solving this equation, you get the equation, this equation, okay, of the original circle, okay. Yeah, so this will be an equation of a circle. So we have z equals to 3. So this means our equation will be x squared plus y squared equals to what? 9. Remember, z is given by x plus y j. So the magnitude of z, this magnitude here, will be given by the square root of x squared plus y squared. Right, together. Therefore, this is the magnitude by the end of the day. If you replace it here, remember this is the magnitude, so you replace it here, you have x squared plus y squared square root should be equals to 3. Are we together? Then how do you remove the square root? You square both sides, okay? So you square this side, you will get x squared y squared. When you square this side, you get what? Equals to 9. So that is the first step. Get the equation of the original function, S of the line. Then from there, you come and evaluate what? You come and evaluate this particular transformation. Now, so you have what is W? So there are some few things you just need to be aware. So W will be given by U plus V plus Vj. So we shall replace where we have a z, we put x plus yj. Where we have a w, we put u plus vj. Now, what is the process of solving this particular equation or finding the image? It is just making x and y the subject of the formula. Then x and y shall be replaced in this particular equation. Are you together? Yes. So that you can find the equation of the image with respect to the equation of the of the image with respect to the original function, okay? Yes, the object. So we have this the object. So from this transformation, you always find a way in which you find the value of x and the value of y. Then you replace them here. Now, replacing our values, our variables here, so we shall have w is u plus vj. So it is u plus vj equals to, what is our z? X plus yj, then minus 3j over x plus yj plus 2j. Right, together? Then collect the real and imaginary terms together. So we shall have our real part only is x here. These are imaginary. X is also real. These are imaginary. So we shall have x, the plus, put y and negative 3 together. So it is y minus 3, then put what? Put j. Then again here it is x plus, put y and 2, then the j outside, okay? Factor out the j. So y plus 2, then j. Right, together. So therefore u plus vj should give you this. Alright? Now, different to inversion, these are bilinear. Bilinear means you have an equation, a complex number in the numerator, a complex number in the denominator. For inversion, we only had the complex function only in the denominator. Right, together. You can check that one out in the inversion question. Now, so since we have a complex number in the numerator and a complex number in the denominator, now our main focus now will be this point. Then we shall come and work with this other point. So now, working on the right hand side. So let me focus on the right hand side here for now. which is x plus y minus 3j over x plus y plus 2 then j. So you have to remove the complex function. You have to remove the function should not be complex in the denominator. And how do you remove a complex function from a denominator? Is you multiply by the conjugate. Are you together? So we multiply by the conjugate of this function both in the numerator and the denominator. So we shall multiply. What's the conjugate of this? The conjugate is you only change the sign where the imaginary part is starting. So in our part here, so if we use a simple function like 2 plus 3j, the conjugate of this will be 2 minus 3j. So where have we changed the sign? From this being positive and this being negative. Are we together? So that is the same, what you're doing here. So x plus this the imaginary part. So we've only changed the sign here. And we are working with only the denominator. So we shall multiply by x minus, so y plus 2, then j over x minus y plus 2, then equal to what? J. Remember, when you cancel this and this gives you 1. Right together. So we are really not changing the function, we're just rewriting it in other forms, okay? But our main intention here is to remove the what? To remove the complex function in the denominator. Now, what do we know about when you multiply complex functions in the denominator? What should be your outcome? When you multiply a plus bj multiplied by a minus bj, the solution is always the first term squared plus the second term squared, positive at the center. Okay, so therefore we are saying in the numerator here, in the numerator we shall have x squared, that is our first term, then plus our second term is y plus 2, then squared, positive. When you multiply this and this, you get the first term squared, the second term squared. Now these are the parts, so you can treat this as 2. Remember from algebra, when you're multiplying x plus y, x plus minus y, for instance. How do you open this bracket? Is x times x times y times x, y times y. The first variable opens the other one, the first variable opens the second. Are you together? Yes. So that is what you're going to do here. But this one is going to be a long, so I'll just put it down here. Because it is their function, they are just not numbers. So it is x squared plus y plus 2. You can expand this. Let me expand this part. So when I expand this, when you expand a term squared, is always the first term squared plus twice the first and the second. So if you multiply this and this, 2y, then times 2. So it gives you 4y. Then the second term squared, which is 4. Right together. The expansion of this part is this y squared plus 4y plus 4. Now let's multiply the numerator part. So we start the first and the first. So x times x gives you x squared. X times the whole of this. So we'll have a negative there. We'll have a negative there. Then it is x times y plus 2j. So you can just say, you can put the x and the j first, then we don't open this first, we just write them that way. X times the whole of this, so it is xj y plus 2, but there's a negative. Yes, so negative, just show them instead of writing the j here, I put it here, together. Yes, so it is x times the whole of this, gives you that. Then you come to the second. This term, multiply by this. So we have multiplied this and that. So again we come to the second. This term and this term. Again we'll have xj, but we have a positive, so plus xj, then y minus 3. I hope we're together up to there. Yes. So it is this term times this term, so it is xj, then y minus 3. So xj, y minus 3. Then the second and the second, so we should have now we have a positive and a negative, so the outcome here is a negative. Right together. So this and this will have y minus 3, y plus 2. Right together. then j and j gives you j squared. And I want us to eliminate the j squared here. Why? Because what is j squared? J is the root of 1, our root of -1. So therefore j squared is -1. So instead of writing j squared here, I can just write -1. Are we together? And -1 and have a negative. So the negative here and the negative here gives you what? Positive. So this one goes and this one here becomes what? Positive. Are we together? Yes. So it's just that. So now from there we can now open the bracket further and so on. So again we have equals to, so the first term again is still x squared. So open this bracket, it will be minus xyj, then the negative goes because you have a negative, this becomes negative, positive again becomes negative, so minus 2x, then j, and together, then you come to the other one, plus xj times y, we have xyj. Then we have this positive, this negative, so we'll have negative minus, then 3xj, so it will be 3x, we have j, then we come away, so we're done with that. Now we come to this point, so this and this gives you y squared, so plus y squared, this and this is y squared, this and this minus 2y, then this and this minus this and this is plus 2y, not minus. Then this and this minus 3y. Then this and this minus 6. So as I was saying, you have a pretty long equation, but all the same by the end of the day expression. But by the end of the day, it's something which is workable. Yes, so we have that. Now again, collect real terms, add and subtract whatever is common, and so on and so forth. So we have x squared, can take another real plus y squared. Okay, there's no other square function. Now here we have plus 2y minus 3y, that gives you minus y. We have minus y. We're taking the real and the real. So we have this real. We have this imaginary, real, then this one is real, and this one. So minus 6. Yeah. So minus 6. Then we take the imaginary ones. So we can put plus, and we put them into bracket. Minus xyj. Is there another xy? Yes, it's here. Minus positive. So this part and this part cancels. This part and that part goes. So this one is a negative, this one is a positive. They are the same, yeah? Yes. Then minus 2xj minus 3xj. Get negative 5x. So negative 5x. Then is there any other j? There is no other j. So it is just only that. So for the imaginary part, it's only one. There's no other, because these and these have cancelled out. This one and this one are added together to get negative 5x and the j outside. Then over x squared plus y squared plus 4y plus 4. Right together? Yes. And now that is your w. So remember here, w vj, so we are solving this other side. So u plus v vj gives you this. So now you can split them into two. You have your u and you have your v, the real and the imaginary part together. So our u part will be x squared plus y squared minus y minus 6 all over the denominator, x squared plus y squared plus 4y plus 4. Then our v part will be given by negative 5x over the denominator, x squared plus y squared plus 4y and plus 4. Are we together? Yes. So we are there. Now remember again, this is not the end, because you're supposed to make x and y the subject of the formula by the end of the day. Then that whatever we get there, we replace it here. Alright? Therefore, now, so something to note. Now, you can see we have x squared plus y squared, x squared, y squared, x squared, y squared. Now, but what is our x squared, y squared from this? X squared, y squared equals to 9. So where we have x squared plus y squared, replace it with what? With 9. So in this one, to simplify further. So this one will be, this and this gives you 9 minus y minus 6 over, this one, this gives you 9 plus 4y plus 4. So if you simplify that, 9 minus 6 gives you what? 3. So 3 minus y over 9 plus 4 gives you 13. So 13 plus 4 y. This minus that gives you that. So our u is simplified to become this. You see that? Yes. Now our v also equals to negative 5x over. So again here we should have 9 plus 4y plus 4. Then v again gives you negative 5x over 9 plus 4 again is 13 plus 4y. The denominators are the same. These are the same. Then you have these are that. Now, so this one is your u and this one is your v in simplified version, because we know that x squared plus y squared is 9. So that is something to note. So it gives you that. Then from this point, now you choose which one is easier to make the subject of the formula. Is it x or y? Now check your two functions, this and this. You can see for the u part, we have our y alone in this function. So it is easier to make y the subject of the formula here than to make it here, because in this point you'll have again a variable of x on the other side. So we choose the one that only has one variable to make the subject. So we can see in the numerators we have a y and we have a y. There is no variable of x. So in this equation we make y the subject. Now, so we have our u and we have our v. We have said we're going to start with u and make y the subject of the formula. There's a glitch there with the recording. Sorry. Now, so we have, so make y, so this is the same as saying it is u over 1. So this part, the denominator here multiplies here, this one multiplies here. So you have u into 13 plus 4y equals to 3 minus y. Then multiply all through by u. So you have 13u plus 4yu equals to 3 minus y. Then take the terms that have y on one side and the other ones on the other side. So this comes here, then goes there on the other side. So you have 4yu plus, so it will be plus y equals to 3. 13u goes to the other side, it becomes minus 13. 13u. Are we together? Then from there, just factor out y. So we have 4u plus 1, then factor out your y equals to 3 minus 13u. Are we together? So I've just taken y from this point. So I've taken y here and I've taken y here. So we have 1 plus 4y. Now, what is remaining? Divide all through by 4u plus 1 to make y the subject. So divide by 4u plus 1 over 4u plus 1. So your y will be, it will be 3 minus 13 over 4u plus 1. Are you together? Yes, and that is your value of y. Now what follows? We make again, so we need to find our x. Together, we need to find x. So now, just come here and again say replace y in v. That is, where we have a y, now replace the value of y, and this is the value of y. So you replace it here. So we shall have on the other side. So it is v equals to negative 5x over 13 plus 4 into bracket 3 minus 13u, this one is 13u, okay, 13u over 4u plus 1, right? Now you can work out the denominator alone first. So you can talk about the denominator, so you shall have 13 over 1 plus, you can open this bracket so that you can have 12 minus 52u over 4u plus what? Plus 1. Right, together. So what is the LCM of this part and this part? It's just 4u plus 1. It's the same as saying multiply the two numbers. So this multiplied by this just gives you 4u plus 1. So the LCM is 4u plus 1. Then 1 goes here once, so you remain with 4u plus 1. Or in short, we're just saying multiply this term here and this term here. So you just have 13 multiplied by 4u plus 1, right? Then 1 multiplied by that. And you can just open the bracket because this one is positive here, okay? So it's just 12 minus 52, 52u, right, together. Then from there, just simplify. So this one again equals to the denominator. That is 13 times 4 is 52 again. So you have 52u plus 13 plus 12 minus 52u all over 4u plus 1. Right, together. Then 52 cancels with 52, right? Then 13 plus 12 into 20 is 25. So you have 25 over 4u plus 1. Now remember, this is the denominator, okay? That one is the denominator. So your v will be negative 5x over 25 over 4u plus 1. So now we have our v. Now remember, we have negative 5x, then we have this one as a fraction. So this is the same as saying negative 5x multiplied by 20, not 25 now. So it will be 4u plus 1 over 25. Remember, we are doing the reciprocal of the denominator, and the reciprocal is 4u plus 1, then over 25. We can have this cancelling with this. By 5 goes 5. So we shall have, our value will be negative x into bracket 4u plus 1, then over what? Over 5. And that is the value of. So let me, this one will not be visible here. So let me rewrite this number. So we shall have our v value. Our v value will be what? Our v value will be now negative x 4u plus 1, then what? Over 5. But remember, we want to make what? We want to make x the subject of the formula. So we divide by this number, but remember there's a negative here. So we shall divide or multiply by the reciprocal of this. So we shall multiply by negative 5 over 4u plus 1. And together. So that this 5 goes with this 5. Yes, the negative goes with the negative. Then this one goes with this. And together. We can have the negative out down here. Sorry, not here. So this negative goes with this negative. And that is just what we do on the other side. So we shall have v multiply. We have that. So we shall have 5 over 4u plus 1. Okay, negative. Then v. We should give you what? Should give you x. So therefore your value of x basically is negative 5v 4u plus 1. Are you together? Okay. Now, so since we have the value of x and we have the value of y, we can now replace them. Remember, we have this equation x squared plus y squared equals to 9. So replace the value of x and the value of y in this particular equation. Okay. So we have that. So we are saying, so my x is this, so negative 5v over 4u plus 1 into bracket squared plus, what was my y? This is here. It is 3 minus 13u over 4u plus 1, then into bracket squared equals to what? Equals to 9. Exactly what we have here is what you replace here. Now expand this. We know a number squares, a square squares every number inside the bracket. So it will square negative 5 into square v, okay? So we'll have 25v squared. Remember, when you square negative, it becomes positive. Then we have 4u plus 1 into bracket square altogether. Then plus this part here shall be expanded the same way you expand any binomial expansion. Yeah, we have the two of them, okay? So you have two terms here. Are we together? So and what do you get when you expand two terms? It is the first term squared plus the first term squared plus twice the first and the second, then the second squared. So the first term squared, which is 9. Now since here we have a negative, it will be a negative. Then twice the first and the second. So if I multiply the first and the second, I'll get negative 39u. So we'll have the negative here. Are we together? Negative 39u. Then times 2, which gives me negative 78u. Are we together? Then plus the second term squared, so it will be 169u squared. Then all over 4u plus 1, then into bracket squared. So we have squared the numerator and denominator. That gives you 9. We can also square this the denominator, but I want to square them when you take them here. So again here multiply all through by what? 4u plus 1 squared. We want to remove the 4u plus 1 from the denominator because it appears here, If you have checked the question on inversion, we always make sure we don't have a number in the denominator. And since it appears here and it appears here, then you can multiply it all through. We just say multiply all through by the LCM of these three numbers. So therefore, then you shall have, so in the first one you multiply with 4u plus 1 squared, you get 25v squared. The second one also, you get the number in the numerator, so 78u plus 169u squared equals to 9. Multiply again with that, so it is 4u plus 1 then squared. But you can expand this so you can get the actual value. So we expand the term here. So it is always the first term squared. Again, expanding this part is the first term squared, which is 4u squared, which is 16u squared. Then twice the first and the second. So 4u times 1 is 4u. Then times 2, 8u. Then plus, then the second term squared, which is just 1. Then from there, expand. So we have 25v squared minus 9 minus 78u plus 169u squared equals to, so we have 16 times 9, 16 times 9, which gives us 144 u squared, that this one will be 72 u, then plus 9. Now take everything on this other side and subtract anything that looks the same. So you have 25v squared. This one is negative. I bring it to this other side. This one is positive, negative. So I'll have, if I bring this 9, I want us to move together. I have a 9 here. So I take it to this other side. You have 9 minus 9. So we'll have a 0 there. Okay? Then you have negative 78u. Now negative 78u, you bring on this side, what do you bring? 72. So it becomes minus 72u. Okay? Then I have 72. This is mine, yeah, it's okay. Then you can add the 2. So you have 78 and 72, which gives us 150. Let's do that. So negative 150u. Then take 144 to this other side. So you'll have 169 minus 144. That should give you 25. So plus 25u squared. So see the 9 and the 9 goes, so equals to 0. Right, together. Then so you shall have, you can arrange them the way equation of a circle, because this one is definitely an equation of a circle. 59u equals to 0. Therefore, divide all through by 25 by 25 by 25. So we shall have u squared plus v squared minus. This one will be how many times? Into 100 it goes 4 times. So it's going to be 6. 6 equals to 0. Are together? Yes. So it is 6, so minus 6u equals to, minus 6u equals to 0. Then from this, so this is the equation of the image. Together. Yes, and this is the image. Alright. If you want to find the radius and the, you can find the radius and you can find the center. Okay, you can find the center and the radius. So how do you find the center? Center is given by negative g, negative f, and the radius is given by square root of g squared plus f squared minus c. So how do you find g? Remember, there is a general way of writing the equation of a circle, and I'll use this form, which is u squared plus v squared plus 2gu plus 2fv plus c equals to 0. So compare your terms according to where they appear. So compare 2g, for you to get the value of g, 2g with whatever you have at u. So it will be 2g, what do I have at u? Negative 6. Okay? 2gu, negative 6u. So 2g should be the same as negative 6. So divided by 2 divided by 2. So our g will be negative 3. Okay, so you have your g being negative 3. So what is your f? You can check 2fv, but do we have a v here? No, so it will be 0. So my f definitely will just be 0. So therefore the center will be negative g. What is the negative of negative 3? It will be 3. Then f is 0. So 3, 0. And the radius given by, just work this one out, square root of, we have g squared, which is 3 squared, negative 3, negative 3 squared, plus f, 0, minus c. Do you have a constant c? No. So 0. So it's the square root of 3 squared, which will just be 3. So your radius will be 3 units.